Good morning, students. Today, in this class, we will discuss some introductory ideas about a new concept that we call as vectors. It's not that you have not heard of this particular word, but we will deal them in detail. I hope you know that things, the physical quantities that we associate some direction with, are called as vectors. For example, a displacement of 2 meter towards east. Here 2 meter refers to the value or magnitude of the displacement, and towards east, that is the direction attribute of displacement. So when we express displacement, we express a value and a direction. Hence we say that displacement is a vector quantity. Likewise, a force of 20 Newton applied downward. So 20 Newton is the value, downward is the direction. So such physical quantities wherein we can associate a magnitude with some associated direction are called as vectors quantity. On the other hand, where the direction is not stated, is not required, such quantities we associate the term scalars. For example, mass. My mass is suppose 70 kilograms. Suppose. So I need not specify any direction to it. It is meaningless. So we say mass of any body is a scalar quantity. So this much I expect you to know. Now, vectors geometrically I can call it to be an arrow. What is a vector? Vector is an arrow, like so. And the length of that arrow, it gives magnitude. Now, what is magnitude? Magnitude means value. For example, 2 meters, 20 Newton. These are values, and that value will be given by the length of this particular vector. Now, let me confine myself to a single vector of displacement. So this length, we will say that it is equivalent to 2 meters. Number one. Number two, direction of the vector, whether it is a displacement vector or any other vector, direction of the vector is indicated by the arrow. So arrow points in the direction of vector. Arrow points in the direction of vector. So geometrically, we can define a vector to be an arrow. Length of that arrow gives the magnitude of the vector, and the direction where the arrow points, that refers to the direction of the vector. Now, before we proceed further, if there be a vector whose magnitude is unity, we give a special name to them. They are called as unit vectors. So we have x, y, and z axis. So this is x axis, this is y axis, this is z axis. Suppose this is the origin. If you move unit length over here along x axis, that is also a vector, and that vector we denote it by I hat or I cap. Likewise, a unit vector, so this is 0, this is 1. A unit vector along y axis, we will call it as j cap. Unit vector along z axis, we will name it as k cap. Just notations are there. Here x, y, and z axis, they are mutually perpendicular to each other, like so. So what we have discussed so far, we represent a vector geometrically with the help of an arrow. If length of that arrow is unity, That means magnitude of that vector is unity. We associate a particular name to that vector. We call it as unit vector. It can point in different directions. If it points along x-axis, we name it as I cap. Likewise, we have j cap and k cap. The vector which you understand the best of this I am discussing as an introductory class. So I would assume that you are beginners in this context. Uh, so the vector which you understand the best is the displacement vector. So suppose we have x-axis and we have y-axis. Let me call it as origin and let me mark some points like so. This is 1, 2, 3, 4, where x and y are in suppose meters. You know geometrically how to represent the coordinates of some point. Suppose I wish to indicate the coordinates of this point. This knows students it is 3, 2. Now what does this mean? This means that its x coordinate is 3 and y coordinate is 2. Vector is also a similar entity. If you understand this in terms of displacement, in order to reach from origin to this point, which I call as A, given the condition that you cannot move directly along this direction, you have to move either along x-axis or along y-axis. Then what would be the path followed by you? There are two possibilities. I can first move till this point, 3 units along x-axis, and then I'll move along y-axis like so. Somebody else, what he could do, he could move first along y-axis like this and then along x-axis like this. Both of them, the end point remains the same. Now let me suggest again what I told. O is the origin. There is some point A, 3, 2. You are given a task to reach to point A from origin. You are constrained to move either along x-axis or along y-axis. You cannot move in any direction. Then only there are two possibilities. Either you move like so or you move like so. This is also a vector. This is also a vector. I have pointed here that the unit vector of unit magnitude along x-axis, we write it as I cap. Now if you see carefully, from here to here, this is I cap. One I cap you can say. Likewise, this is I cap. This is I cap. 3 units are you are moving along x-axis. Therefore, this vector should be represented as 3 I cap. After reaching to this point, then we take a 90-degree turn and then we move 2 units along y-axis. This one. Now see, this one is j cap. This is y-axis, this is j cap. And this will be another j cap. So we have 2 j cap. So here this vector will write as 2j cap. This is stated like so that the vector OB. Now what is vector OB? Vector OB is this vector starting from O ending at B. When we write AB vector, it would mean that vector starts from point A, terminates at point B. So this OB vector, sorry, this is OA vector. OA vector. Okay. So if you are asked that you have to reach to point A, our resultant effect is OA vector. But how did we go to that point? First we moved 3 units along x-axis. That we represent as 3 along x-axis means 3 I cap. Then after that in vectors, then I can denote by this plus. That means we are adding, we are finding the cumulative effect of two particular vectors. So there was a vector of 3 I cap. There is a vector of 2 j cap. We are adding their effects, not their values. We are not adding 3 plus 2. We are adding their effects. So I move 3 units in this direction. I take 90-degree turn. I move 2 units in a particular direction. The effects we are adding. So here we will write now this vector. This vector is nothing but 2j cap. So when you find somewhere in your textbook that, of course, we should write here meters, 3 meters I cap plus 2 meters j cap. When you find a vector written in this form 3 I cap plus 2 j cap, this picture should come into your mind. That means it has a component of 3 along x-axis and there is a component of 2 along y-axis. Now some more things we can write here. If you see this particular vector, let me name this as C. A to C is also a vector. This is also a vector. C to A is also a vector. Let me name this as D. OD is also a vector and DA is also a vector. Let us try to write these vectors. So you can easily write them. AC vector, sorry, OC vector I used to write. OC vector is 3I cap. C to A, this vector is how much? 2j cap. OD vector is 2j cap. And likewise DA vector is 3I cap. Now as I wrote this one, I can also write OA vector as I told, instead of moving this way, I can follow the other path. First 2 units this side, then 3 units along x-axis. So I can also write it as 2j cap plus 3I cap. No harm in that. But 3I cap is this vector, that is OC vector. And this one is a CA vector. So here we got an important thing, that OA vector is the resultant of the effects of OC vector and CA vector. In another form, you can say OA vector is the resultant effect of the effects of these two vectors. Which two vectors? OD vector and DA vector. In fact, we can state that OC vector and DA vector, these two, are same. Likewise, CA vector and OD vector are same. So in books you'll find equal vectors, unit vectors, such definitions you'll find. You can understand it directly. You can write the definitions from there. Equal vectors means they should have same magnitude, they should have same direction. So this and these vectors have same magnitude to units, same direction along y-axis. Therefore, I can write OD vector is equal to CA vector. So these are some very introductory ideas about vectors. Now we will proceed further to addition of vectors and components. But before we learn addition of vectors, this only I would like to elaborate more. We say we can associate some name to this vector. OA vector, I'll call it as small a vector. When you write a vector, we put an arrow mark over its symbol. So here this is a vector. When we are writing that OA vector is 3I cap plus 2j cap, it does not mean 3 plus 2. As I told, it means the resultant effect of 3 units along x-axis and a vector of 2 units along y-axis. So this plus this is geometrically this one. Okay. This vector we have called it as a vector. So to reach, for example, if you consider displacement vector, to reach this point we are moving 3 units along x-axis and 2 units along y-axis. These 3 units we say is the x component of the resultant vector. Likewise, this 2 unit is the y component of the resultant vector. So x component of this vector is, we'll write it as ax. And how much is that? That is O to C. And that is 3 units. If it is a displacement, we can write meters. Likewise, y component of a vector, that we will write as a subscript y, and that will be how much? this one or this one. Either you can write OD or you can write CA, and that is how much? 2 units. So when there is a vector like this, suppose I take another example. Suppose there is a vector B and it is written 3 I cap plus 7 j cap. That means x component of B vector is 3 and y component of B vector is 7. That means to have this vector, you have to move 3 units along x-axis if you are considering displacement, and 7 units along y-axis. So you will reach to the point whose vector representation is B vector. Okay, let us understand one more example quickly. So here we have 4 I cap minus 3 j cap. So you have to move 4 units along x-axis and 3 units along minus of j cap. That means negative x-axis, negative y-axis. So just as I cap means you have to move along x-axis in the positive direction of x-axis, minus I cap would mean a vector of unit magnitude but in opposite direction. Likewise along y-axis and z-axis. So let's see, we have to start from origin. We'll start from our origin, that is this point. 4 units along x-axis. So this is 1 unit, 2 unit, 3 unit, 4 units. So this is the vector. This is the first vector. And this vector is 4 I cap. Then we have to move 3 units along minus j cap. Now this is the direction of y-axis. So opposite will be the direction of negative y-axis. So we have to move in that direction. And how many units? 3 units. So 1, 2, 3. So from here 1 unit, 2 unit, 3 units. So we'll reach somewhere here. And this vector will be minus 3 j cap. So where do we reach is this point. This point I'll call as C. This is O, suppose this is A, this is C. Then this C vector is this one, OC. This we write as C vector. And this we can also write as OC vector. This C will be small, this is capital. Actually, I should write it a bit bigger, but I hope you understand that. Here we will write that OC vector, which we have written as C vector, is equal to 4 I cap minus 3 j cap. Likewise, we can choose other combinations like minus 4 I cap plus 3 j cap, minus 4 I cap minus 3 j cap. If you understand the coordinates, you understand the vectors. Now suppose that vector, any general vector, makes some angle theta with either of the axes. Here I have drawn it to be at an angle theta with x-axis. And its length of this vector is given to be, suppose, b. This is another way of representing a vector. So either you specify the coordinates of the endpoint, for example 3, 2, 2, 5, 1, minus 2, etc. Either you specify the x and y components, or you specify the length of the vector, that is b, and direction, magnitude and direction. This is magnitude, this is direction. Both of them are different ways of expressing a vector. If it is in this form, then we can easily obtain its components along x and y axis. Just we need to drop a perpendicular. First we move along this axis, then we'll move along this axis. How much will be this? Now you can see this triangle, which is a right angle triangle. So we can see that cos theta is this by this. Now this one is the x component of B vector, which we know we write as Bx. Likewise, this vector which we'll have will be represented as B of y. So x component of B vector, y component of B vector. Now you see in this triangle cos theta will be Bx upon B, where B is the magnitude of B vector. So here we write it like this, that magnitude of B vector is equal to B. So this gives us the x component Bx as B cos theta. And likewise, sin theta will be By upon B. So our By becomes B sine theta. If magnitude and angle are given, then the x and y components of the vector can be obtained like so. Note that here theta is the angle made with x-axis. We can have a situation like so, wherein there can be a vector like this. This is our x-axis, this is our y-axis, and let this vector be A. And suppose this angle is 135 degrees. Then x component of a vector and y component of a vector, if it is asked, x component of a vector will write ax, y component will write as ay. X component is the component ax, which will be given using this formula. Just as we had written bx is equal to magnitude of b times cosine of angle that it makes with x-axis, likewise magnitude of a vector, which we write as a, suppose it is given, times cosine of angle which this vector makes with positive direction of x-axis. Positive direction of x-axis, do not consider this angle. So angles, students, they are taken to be positive in the anti-clockwise sense. Starting from x-axis, you have to move to this. So this becomes 135 degree. You can find it easily. Likewise, this will be a sine 135 degree. If you find, you will find this will be negative a by root 2 and this will be plus a by root 2. So that I leave it to you to find yourself. So these are some preliminary ideas regarding vectors. Now we shall see how this is about a single vector. But if we have more than one vectors, how do we add them? How do we see their resultant effect? In principle, we have already seen that. For example, this is one vector, 4I cap. This is another vector, minus 3j cap. And their combined effect is this resultant. So this we have seen. But whatever we have seen so far, both those vectors, the component vectors, were along x-axis and y-axis. What would happen if they are not along x-axis and y-axis? That is the general case which I would like to discuss now. So let's see that. Suppose we have our coordinates like so. This is our x-axis, this is our y-axis. Suppose we have a vector whose end point is this one. Let me name it as A. So what is our OA vector? Our OA vector will be, students, drop perpendicular from the tip of the vector. So to reach to this point, I have to move 3 units along x-axis and 2 units along y-axis. So our OA vector will be 3 I cap. This is I cap, I cap, I cap. This is j cap, j cap. So 3 times I cap plus 2 times j cap. This is our vector. Now suppose from here, suppose you ask somebody, you move 3 units towards east, 2 units towards north, you reach to a point, again move some units towards east, some units towards north. So suppose we move 4 units, 1, 2, 3, 4, 4 units from here, or let us say 5 units towards east, and then one unit. How let me add the positive values only. Let me reduce it. 2 units towards east and then 3 units towards north. Let me make it 4 units. From A to this point, which I'll call as B. So let me draw that vector. How much should be AB vector? Now AB vector, we are not starting from origin, so we need to be careful. But AB vector, if I ask you to go from A to B, you will move some units along x-axis, some units along y-axis. See this and tell me how many units you need to move along x-axis if you start from A. It is this one. That is 3 to 5. So this is I cap, this is I cap, 2 units. So 2 I cap. And from here you are moving this much. This is same as this. So I cap, I cap, I cap, I cap, 4, sorry, I should tell J cap. So 4 J cap. So OA vector is 3 I cap plus 2 J cap, AB vector is 2 I cap plus 4 J cap. Now my question is, what is the resultant effect starting from O? So the resultant effect starting from O, the final point is this one. So this is OB vector. So we say OB vector is the resultant of OA vector and AB vector. Very important to understand. Now let us see what would be the values for the x and y components of OB vector. Instead of moving along O to A and A to B, if suppose you give the task, here we did the operation in 2 steps. First we asked him, the person, to reach to point A from O, step number 1. And then we asked him to go from A to B. But if you ask him to complete this in one step only, directly from O to B, with constraint that you have to move either along x-axis or along y-axis, then he will move from O to this point and from this point to this point directly. Then also he will reach to the same point. So our OB vector, if you see carefully, students, will be how much? He will move till this point. So 5 units along x-axis. And from here to here, that is 6 units along y-axis. Now please hold and see the relation between these vectors. OA vector, AB vector and OB vector. If you see carefully, students, you will find if we add the x components of these two vectors, OA vector and AB vector, you will get the x component of the resultant vector. See, this is 3, this is 2, and this is 3 plus 2, that is 5. This is 2, this is 4 y components, and 2 plus 4, that is 6. And it's for this reason we write that OB vector, the final vector, is the resultant of OA vector and AB vector. What we have written in words over here has been expressed in another language in this form. Representations are different, they mean the same thing. And if you see carefully, their x components, I'll use this notation. Suppose I have a vector A, its x component I'll write as AX, y component I'll write as AY. The x component of OB I'll write as OBX. The x component of OA I'll write as OAX. The x component of AB I'll write as ABX. If you see carefully, the x component of OB vector is 5 The x component of OA vector is 3 and the x component of AB vector is 2. So I can write this is equal to this plus this. 5 is equal to 3 plus 2. Likewise, 6 is equal to 2 plus 4. 6 is the y component of the resultant vector. Y component of OB vector is the sum of y components of OA vector and AB vector. So that also we can write. So OB y component is equal to OA y component plus AB y component. This is the meaning of resultant. So let me summarize. If some place, suppose the resultant vector I write as R vector, as it is the resultant of two vectors say A and B. What does it mean? It means that the x component of resultant vector is a sum of x components of A and B. Likewise, the y component of the resultant vector is the sum of y components of A vector and B vector. So please, if you are beginning vectors for the first time, understand these particular concepts very carefully. If you have understood, then continue this particular lesson. Here, what you see is a shape that we know as a triangle. And this figure is usually what is explained in the textbooks as the triangle law of vector addition. Triangle law of vector addition. I am redrawing that figure, or I can explain here only. So here we have written this OB vector is the resultant. So this is the resultant. If we have understood this much, then there is nothing new in this triangle law. What you see here, that has to be put in words, that if two vectors are represented both in magnitude and direction by two sides of a triangle, then their resultant or cumulative effect is represented by the vector which runs from the initial to the final point, that is third side of the triangle. If I have one vector like so, which I call as A vector, I have another vector like so, which I call as a B vector, then this vector, the third side of the triangle, will be the resultant, and we write R vector is A vector plus B vector. Now, when I say A plus B, it does not mean, for example, 2 plus 3 and so on. It means that we have to add the x components of A and B vectors to get the x component of R. So, like so, AX plus BX will be RX, and likewise, as I have explained earlier, for Y component. So, any two vectors, if they are given, you can find the resultant by finding the third side of the triangle. This is geometrical method for finding the resultant of two vectors. Now let us consider two vectors. Suppose A vector is a force of 2 Newton towards east, and B vector is a force of say 4 Newton at an angle of 30 degrees or let me make it 45 degrees north of east. This is a question. Find resultant. See, I don't intend to give here basic formulae which you'll find. There are some formulae for this. But if you have the concepts being discussed here in your mind, you can solve it easily. So let us quickly see its solution. So this is our x-axis. This is our y-axis. Now let us first draw a vector. Now our x-axis I will take as east direction. So negative x-axis, that becomes west, this will be north, this will be south. So this is east, this is north. This is our origin, so we begin from our origin. there is a force of 2 Newton. So far we have discussed about displacement, but that is also true for force because that is a vector quantity. 2 Newton towards east. So suppose we make some margins. So 2, this is A vector. 2 units towards east. Now B vector is 4 Newton, 45 degrees north of east. From east you have to make an angle of 45 degree, and then you have to make a vector whose magnitude is 4 Newton from here. Do something like this. This angle is 45 degree. This is another vector and its name is B vector. Okay. We have to find the resultant of these two vectors. The resultant of these two vectors, as per our triangle law, is this one. The third side of the triangle. So R vector. So we have to find R vector. How do we do that? Just you have to use geometry. You are given two sides of triangle, you are given some angles, you have to find the length as well as direction for that particular vector. So let me name this as O, this as A, and this as B. This angle is 45 degree. Okay. How much will be this? First we'll find. Now see, let me name this as M. In triangle ABM, this angle is 45 degree. So cos 45 degree is AM upon this length. Now this is the length of AB vector, but AB vector which we were making, that was having a value of how much? 4 Newton. So this is 2 units and this is 4 units. So this I'll write as 4. And sine 45 degree, if you see in this triangle, will be BM upon this hypotenuse. This hypotenuse is again 4. So this gives us the value of AM and BM. So AM becomes 4 by root 2 Newton, and BM becomes, or MB becomes 4 by root 2 Newtons. Okay. So both AM and BM will be equal, and they are 4 by root 2 Newtons each. Now we have to find the resultant, means this OB vector. So we have to find R vector, its length. So OB length we have to find. To find the length OB, that is nothing but resultant's magnitude, we will use Pythagoras theorem. So this is under root OM square plus MB square. So this becomes under root OM. OM is, you can see, OA plus AM. OA is 2, this one, plus AM we have already found, 4 by root 2 whole square, plus MB square. MB we have found earlier, 4 by root 2, so that is 4 by root 2 square. So we have calculated the value of the resultant force. What is the meaning of this physically? That if there is an object and a force of 2 Newton acts towards east, and a force of 4 Newton acts in this direction at an angle of 45 degree from east towards north, like this. So one is 2 Newton like so, one is 4 Newton like so. Then the resultant force will have a magnitude of this much Newton. Now I leave it to you to calculate this. Now this is the resultant, but this is not sufficient to specify the answer. Resultant is this much Newton, but in which direction? Is it along north? Is it along east? Is it making some 40 degree, 45 degree, 20 degree? What is the angle which it makes? That is also to be stated. Now for that, you can see, students, I am rubbing this part. So we have calculated the magnitude. Now we have to calculate the direction. Direction means at what angle from east or from north this force acts. That means we have to find this angle. Let this angle be alpha. So tan alpha, if you see, so you can write let the resultant r vector make angle alpha with x-axis, or yes, x-axis you can write, because our x-axis is pointing towards east. You can also write let it make an angle of alpha with east direction. Then in this big triangle OBM, you can see tan alpha can be written as the perpendicular by base. Now what is the perpendicular? BM, and the base is OM. So BM will be how much? BM we have already calculated, 4 by root 2, and OM is OA plus AM. OA is 2, and AM we have calculated 4 by root 2. 2 plus 4 by root 2. Now this, if you calculate, you can use trigonometric table for tangent of angle theta, tan theta. You can see the trigonometric tables, and then from then that table you can calculate this value of alpha. So I'll leave it as such. Usually it is expressed like so. If tan alpha is this much, alpha we write as tan inverse of this quantity. So my intent was to explain the method. If two vectors are given, how do you find the cumulative effect? How do you find the resultant effect? So here what concept we are using? We are using that concept of triangle law. Okay. Now we'll proceed further from here in the next class, because this was introductory class. So I hope the things are clear. Please put them in your mind, understand them, and we'll proceed from here further in the next class. Thank you, students. Take care. Read.